All right, this is 6th grade, Unit 1, Lesson 10. And in this lesson, students are going to continue really exploring that base and height relationship with the area of the triangle. So we're going to be using that formal, official algorithm, base times height divided by 2, or base times height times a half, or 1/2 times base times height. Man, any of those work. And we're going to continue doing that, but this time we're really going to kind of help our students become flexible about, well, what's the base and what's the height? And because we have a lot of flexibility, the base doesn't always have to be the thing that looks like it's on the bottom. So that's what this lesson is all about. So let's get started. All right, and so we're looking here at our worksheet kind of a thing, and we begin with this idea of we have an interactive digital version if you want. We can just take a look at the old school paper version, which is right here. It says on the grid, draw a triangle with an area of 12 square units. Try to draw a non-right triangle. Well, let's start with a right triangle. So we remember that the formula of how you find the area of a triangle is, it's going to be base times height divided by 2. Or you could say 1/2 times base times height. They both work. And so the idea is, if we want that answer to equal 12, we know we need to do base times height and then divide by 2 to get 12. So we know we need our base times height to equal 24. So an example would be, a height of 4 and a base of 6. 1, 2, 3, 4, 5, 6. There is our triangle that has an area of 12 square units. Now, they asked us to try and draw a non-right triangle, but we started with this one because this is the easiest one to get us started with. But the idea is, any triangle with a base of 6 and a height of 4 would work. So we could, here's our base, 1, 2, 3, 4, 5, 6. There's our base of 6. Now our height of 4 could look like this. There's our triangle that has a base of 6 right here. There's our base of 6. Now, what the heck is our height? Well, if we're claiming our height is 4, let me just draw it out here. Boom. There's my height of 4. Now, how do I know that this triangle has a height of 4? Because check that out right there. There's my base, and I'm running the line along the base of the triangle down here. I'm running it down there, and wherever it reaches up to, the height of where it reaches to, boom, right there is the height of the triangle. And this line right here, and I don't need that little piece right there, so we can see that this line has a height of 4 because we can see it. It's 1, 2, 3, 4. So it has a height of 4, which means this triangle has a height of 4. So there is our triangle. It has a base of 6. It has a height of 4, which means we automatically know it's going to have an area of 12. So there you go. It's kind of fun. Now, we could have used the interactive version. So let's take a look at that interactive version. Over here, it's a Geogebra applet. And the idea is we can create a triangle. Here it is. Boom. And I'm going to click, 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 and finish it off by clicking. So there we go. We have a triangle, and I can move it around if I choose. And it kind of snaps into place. Boom. On the at the grid. And then so we can make a base of 1, 2, 3, 4, 5, 6. There's my base of 6. And I need a height of 4. 1, 2, 3, 4. Now I've got a height of 4. And all of these, anywhere along this line, is going to be a height of 4. In fact, I could do that. I could say, let's just create, there's my line, and it's a height of 1, 2, 3, 4. So this line right here is officially 4 units above the base of my triangle right there. So really, I could take this, and as long as it's somewhere on this line, any of these triangles they're all going to have the same area of 12 units, 12 square units, because it's that height of 4. Remember, 0, 1, 2, 3, 4. There's my height. And any of these triangles are going to have a height of 4. And of course, they're going to have a consistent base of 6 because that's not moving at all. So all of these triangles have an area of 12 because they have a base of 6 and a height of 4. Kind of interesting. So let's get back to our worksheet kind of a thing. So we're going to be hunting for heights. So here's 3 copies of the same triangle, but they kind of rotated it around. So you get that classic base as the bottom is your base, kind of like we're familiar with. Now for each of these, we're supposed to use an index card to help us. So check this out. So basically what we're going to do is we know that this is our base. So I'm just going to draw a nice line here. And let's do purple. So this line is going to be our height finder. So as I bring it across the triangle, the area right here, oops, well, go away, there, right there, where it kind of crosses this triangle, that's going to indicate where the height is. So of the triangle, right here is the maximum, the height of the triangle right there. So that is our height. So if the green here is our base, then this, I'm going to make it blue. This blue portion right here is the height, because as we drag it around, boom, that's where it is. Oops, went too far. Boom, perfect. Okay, so let's repeat that process. I'm going to do a little bit of erasing here. Erase. Good. Okay, so now let's do it again. So we're going to extend the base. Oops, I did not do a good job of drawing it. There it is. Okay, and then, of course, let's do our height finder, and it's just a perpendicular line of arbitrary length. And I'm going to drag this across my triangle till I get to the highest portion of that triangle. Boom. And that is my height. So this portion right here is my height, because as I'm dragging it around, that's where it is. So if I wanted to, I could get rid of that, get rid of it and delete it, because that is going to show me where the height of my triangle is. So whereas this triangle, in fact, let's get rid of that purple portion. So whereas this triangle, the height is inside the triangle, this triangle, the height is actually outside of the triangle. All right, inside height, outside height. I just sort of made those words up. So last one, let's kind of same idea. We're going to extend that. We're going to extend that base. We're going to use a purple to create our height finder, so to speak. And then, oh, right there, boom. So as I go along the base of the triangle, wha-bam, right there, that's where we suddenly get our height of that triangle right there. And so we can get rid of that guy. We don't need him anymore. And that is our height of that triangle. All right. Now, the lesson itself actually has students using an index card. But I didn't do that. I used a little bit of technology, and I just used a line and slid it across the base down there. All right, draw a line segment to show the height for the chosen base in each triangle. So they're saying, remember, they're saying if this is the base, we need to find where the height is. And the height is going to be right here, because if I slide it anywhere along the triangle, that is the maximum. That's where the height is. Okay, and so this one, if this is the base, so I'm going to zoom in a little bit. We know that the height has to be perpendicular. In fact, I want to make that, oopsies, I want to make that purple, because let's be consistent. So there it is. So we know that this is going to be the height finder. So as I drag it along, whoa, get up there. So as I drag it along the triangle, the base of the triangle, that's going to indicate where we're going to see where the height is. And the height is, boom, right there. So that's where the height is, right there. And then we can get that out of the way. And you can see it's a right angle right here. And it extends in the maximum right there. Good. So I'm going to get rid of that guy. And you're getting the idea. So let's do one last one. I'll just do E. So if that's the base, so I'll get my green. There's my base. And I'm going to use an arbitrary length for create that right angle down here. And I'm going to slide this guy. And this is going to tell me where my height is of this triangle. And as I go, I can see I haven't reached the height. I've actually exited the triangle. There is my height, right there. And so this piece right here is the height. And I can move that height finder, get it out of the way. And so technically, we kind of need to extend the base so that we can see what the height is. The height is right here. Boom. Right there is the height. All right. So you could see sometimes the height is inside the triangle, as in the case of A and B. Sometimes the height is actually outside of the triangle, as in the case of E. So some bases are better than others. What the heck does that mean? It means sometimes the height is pretty easy to find, like in the case of A and B, but sometimes the height is a little tricky to find, as in the case of E. And that's really what they're talking about. So they just want us, let's do this, identify the base and the height. If we need to, we might have to draw a line segment and all that sort of stuff to demonstrate the height. And then find the area. All right, so let's get to it. This triangle, the base, pretty straightforward. The base is right here, and it's a 1, 2, 3, 4, 5, 6, 7, 8, 9. So the base is 9 units, and the height right here is 1, 2, 3, 4, 5. So the height is 5. I didn't draw it quite perpendicular, but it's darn close. And you can see, boom, there is the height. So what's the area of this triangle? So we know that the area of this triangle is going to be, area is equal to base times height divided by 2. All right, and so that's going to be 9 times 5 divided by 2, which is 45 divided by 2, which is finally 22.5 square units. So this triangle right here, this whole triangle is made up of 22.5 squares. And that's what that means. All right, B. All right. Well, the easiest base on this one is not going to be this side one over here. It's not going to be, oh, I want green. It's not going to be this side one. That's because that's diagonal. That's a, it's not easy to count the exact number of units. So that's why that base is not a good one to use, although technically we could. This base is not a good one for us to use because we don't know the exact length because it's all these diagonals. So that's no good. So the only base that's really easy for us to do is this one way up at the top. And we can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's got a length. The base is 11 units. Now, if that's going to be the base, we need to find what the height is. So I just made my my height finder, so to speak. And let's make it a little thicker. And there's my height finder. And we're going to drag it across the base. And remember, in this case, the base is way up here. Whoa, go away. There, the base is up here at the top. This whole thing up here is the base. So I'm going to drag our height finder across the base until I get to the height, which is, boom, right here. It's actually outside of the triangle. So there's our height of the triangle right here. So I can officially get rid of our height finder because it has done its job. And our height of this triangle is 1, 2, 3, 4, 5, 6, 7, 8. So our height is 8. Our base is 11 right here. So our area is equal to base times height divided by 2, which is going to be 11 times 8 divided by 2, which is 88 divided by 2, which is 44 square units. So this huge triangle here is made up of 44 square units. And I don't know if it looks like it, but that's the right answer. So that's the idea for all of these problems. So I'm going to leave it up to you to do the remainder of those triangles. Here's a nice little practice. Find the area of the triangle below. Show your reasoning. So this is a beautiful one. And I'm not going to give you much hint other than to say this one, it might be easier if you see what is not part of that blue triangle. There you go. There it is. So we know the whole, cool. So we know the area of this green. So imagine, what do I want? There. I want to find the area of the green square. What is the area of that green square? Well, that's actually pretty easy because we know that it is a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a height of 12. I'm guessing it's a width of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So that whole square is 12 by 12. So we know that 12 times 12 is 144. So the entire square is 144. But you need to subtract out this missing triangle, this missing triangle, and this missing triangle. So when you find those three missing triangles, you got to subtract them out. You got to take away triangle A, you got to subtract out triangle B, then you got to subtract out triangle C. And once you've subtracted those things, you are going to be left with triangle D, the thing that we're looking for. So it's 144, subtract out A, and whatever you have, then subtract out B, then whatever you have, subtract out C, and that is going to give you your remaining answer, which is the area of D. All right, so there's our summary. You can read through the summary on your own. Go ahead and pause at any moment. But the idea of using that card is a really cool idea, parents and teachers, to help students see for any base, what would the height be? That's kind of cool. That is kind of cool. So let's take a look at some practice. So for each triangle, a base is labeled B. Draw a line segment that shows its corresponding height. Use an index card if you want. So we know if this is our base, and this is our base, and this is our base, we know that we are going to use a perpendicular line, and it doesn't matter how long our line is, it's just got to be perpendicular. And then we slide it around along the base, and that's going to tell us right there, because that's where the kind of like that opposite vertex, that's the maximum length to show us the height of that triangle. So in this case, the triangle's height is right here. And in this case, as we slide it around along the base, we see that the maximum is right there. So the height is right here. And then lastly, this guy is a little tricky because it's on a slant. We see that the maximum is actually right there. That's where it is. Because we kind of need to, in this one, we need to imagine the base getting extended. And there it is. So we can see that our height is right there. And that's going to give us the height of that triangle, which is right there. So now if I wanted to, I could delete my height finders, and there's our resulting heights of each of those triangles. That's kind of cool. So select all the triangles that have an area of 8 square units. All right, so ladies and gentlemen, this one we're just going to kind of go quick. You know your formula is base times height divided by 2. Or you could say 1/2 times base times height. And so the idea is you got to identify your base and your height. You're going to multiply them together. So find your base and your height, multiply them together, and then you're going to divide by 2. All right, and so for each of these, here's our base, it's 4. Here's our height is 4. Done. Here's our base is 4. Uh-oh, what's our height here? In that case, it looks like the height is 4. If you count, you can see it's 1, 2, 3, 4. So yeah, it's got a base of 4 and a height of 4. How about question C? Well, it's got a base of 3. What's its height? Our height is right here. And it looks like it's 1, 2, 3, 4, 5. And our base is 3. So there's your base and height. Once you know your base and your height, you're just going to multiply them together and then divide. Similarly with D and E. I'll do D. I'll leave E up to you. So where's our base? Here's our base. Our base is 1, 2, 3, 4. And what's our height? Oh, our height is actually going to be outside of the triangle. Here is our height. And how do we know it's our height? Because we're going to drag it along the base until we reach the top of the triangle. Wabam, right there. And so we can see that our height there is 4. So we have a base of 4 and a height of 4. And I'm going to let you solve problem E on your own. So each time you're going to find the base and the height, multiply them, and then divide by 2. All right, find the area of the triangle. Show your reasoning. Well, let's use the formula. The formula is base, let's do 1/2 times base times height. So what's the base? Any side would work, but this one seems the easiest. 1, 2, 3, 4, 5, 6. So the base is 6. the height is going to be right here. There's the corresponding height. It's 1, 2, 3, 4. So the height is 4. Isn't that weird to say that the base is this thing on the side and the height is going across instead of going up and down? It's kind of a tricky use of the language, the math language. So then we have 1/2 times 6 times 4, which is going to be 1/2 of 24, which is 12 square units. So side D, can side D be the base of this triangle? So where is side D? Well, here's side D right here. Can that be a base? Of course. Any of the sides of a triangle can be the base of a triangle. Now, if D is your base, what's your height going to be? Well, remember, here's your height finder. Your height finder's got to be perpendicular to the base. And then you just drag it. And you keep going. Boom, there's the height. But they don't have a letter there. So we're going to keep going, and it's going to be G. So let me show you why. So we've found beyond a shadow of a doubt that that is our height right there. So right here is our height. So the red section is our height. And if I just drag it and keep it moving, boom, G is the same thing as our height. G is our height. All right, so what's the corresponding height? What would be the corresponding height? And the answer is G. All right, find the area. Oh, goodness gracious. Find the area of this shape. Now, remember, finding the area, we don't have to use fancy formulas. Finding the area of this shape can be as simple as just let's count all the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 so far, and I'll put the 12 in red because that's the 12 whole squares. Let's put them together in green. Looks like these two go together to equal 1. Looks like these two together go together to equal 1. Looks like these two together equals 1. These two pieces equals 1. These two pieces equals 1. And these two pieces equal 1. So it looks like, in terms of the green, we have 6 pieces, 6 whole squares for the greens and 12 for the red. And it looks like everything is present and accounted for. So we add those together and we get 18 square units. So there's no fancy formula. We didn't have to use a fancy formula. We didn't have to use the triangle stuff that we've been learning. So that's a nice review problem. So the area is 18 square units. Sweet. And then on our last problem, woohoo, on the grid, sketch 2 different parallelograms that each that have equal areas. So, boy, this is review. You got to remember parallelograms. And remember, a parallelogram is one of those kind of like slanted, well, it doesn't always have to be slanted, but it looks like a rectangle in a windstorm, right? And so we want to create 2 parallelograms that have equal area, meaning their base and the area of a parallelogram is base times height. So we just need 2 parallelograms where the base and the height multiply to get the same, have the same product, right? So I'm going to use, 4 times 6 is 24, and 3 times 8 is 24. So that's my 2 parallelograms. So my 1 parallelogram needs to have a height of 4 and a base of 6. So check this out. 1, 2, 3, 4, 5, 6. And I'm going to copy that. So that's the base. Copy and paste it in. So there's my base of 6, a height of 1, height of 2, height of 3, a height of 4, but that looks awfully like it's about to be a rectangle, which technically is a parallelogram, but we won't tell anybody that. So we could just move it a little over, boom, and now all of a sudden I have a parallelogram that still has that base of 6, and it still has a height of 4. So if I wanted to create a second parallelogram that is 3 by 8, has a base of 8 and a height of 3, I could do that. So 1, 2, 3, 4, 5, 6, 7, 8. So there's the base of my second parallelogram. 1, 2, 3. There's my height, and I could just move it over 1 if I wanted to. There's my parallelogram with a base of 8 and a height of 3. And these two parallelograms, the green one and the purple one, have the exact same area. All right, so ladies and gentlemen, that wraps up 6th grade Unit 1, Lesson 10, where students are really making use of their understanding about the formula for the area of a triangle. Really, we're just getting creative with finding that base and height and the corresponding height.